Good morning, everyone.
Morning, Joe.
How are you all today?
Okay, Joe.
Okay. Isaac? Isaac, can you hear me? No, Isaac. Okay. Isabel? No. Abigail? Where's everyone? Abigail, are you there?
Yes.
Carlos? Carlos not there. Elijah?
Here, Joe.
Rishka?
Here, Joe.
Ricardo?
Here, Joe.
Pooja, not here. Sureka? Sureka and Pooja, not here. Aaron, look. Zarit? Michelle? Also no. Malcolm? Judith? Celeste is here. Okay, anyone I didn't call? Noah? Okay.
Me, Joe.
Oh, I didn't call
Jared.
Jared. Oops, sorry, Jared. Okay, Jared is here. Jared, you're not on WhatsApp, is it? Oh, you are on WhatsApp.
No,
Oh, you're using your mom's number, is it?
yes, sir.
Okay. Okay, let me just post it in the group and then we can start. Today we will be discussing these questions that I posted last week. Just give me a moment, yeah. Let me just post in the group. Okay, so let's start today's class. Okay, let's look at these questions. Oh, Isaac is here. Okay, Isaac, your microphone doesn't work. Isaac, does your microphone work? Oh, okay. Okay, let's start. Okay, the diagram shows a man pulling a child on a sledge. Okay, so the acceleration is 1.5 meter per second per second. The mass is 38. State the equation linking force, mass, and acceleration. Who wants to try?
Force equals mass times acceleration, Raja.
Correct. So they're saying state the equation that links force, mass, and acceleration. It is force equals to mass times acceleration. So that's your answer for number 1A1. 1A1. Okay. Let's go to the next one. Calculate the force needed to produce this acceleration. So I have 1.5 as acceleration and 38 as mass. So what is the force? So we use the formula that you used just now. Force equals to mass times acceleration. So what will you get?
7 Newton.
Sorry?
7 Newton.
7?
57.
57, correct. So you just take mass times acceleration. So mass 38 times acceleration, which is 1.5, will give you 57 Newton. Okay, you must have the unit Newton. Okay, at any time, if you didn't get it or I'm going too fast, please let me know. Okay, if not, I'll just continue going. If let's say if you have a question or you didn't get that answer, you got something else, make sure you say something. Okay, if not, I will just take it as everyone got the answer that I'm stating or your friends are stating. Okay, let's continue. So force equals to 57 Newton. Okay, suggest a reason why the force exerted on the sledge by the man must be greater than the force that we calculated earlier. Why? Because the number 2 is theoretical value. That means it's a value that we calculate. So it's 38 times 1.5. It's just direct calculation. But it says here, they suggest a reason why the force exerted on the sledge by the man must be greater than the actual calculated force. So why the force, the actual one when he pushes the sledge, must be greater than what we calculated? Why?
So I wrote, in order for the man to move the child on a sledge, for him to move that child, he needs to have a greater force.
But then we already calculated the force one. Now they're saying, so what it means is 57 Newton is the calculated force. But in real life, it might be extra, like maybe 60 or 65 Newton. It must be greater than what we calculated. Because calculation, you must remember, when we do theoretical value, it is like the ideal situation. But it's saying, no, it has to be greater. Why must it be greater? Why I calculate one value, but in real life, what is the difference between real life and a calculated value?
There's air resistance, friction, and other forces.
Correct. So in real life, there is air resistance, there is friction, and all these things. There is drag that will slow down the sledge. So that is why in real life, the force exerted must be greater than what we calculate. Because when we calculate, it's ideal situation, mass acceleration, that's it. It doesn't take into account like, what is that? Like friction and all that kind of stuff, because I'm just taking two values and multiplying it. So but in real life, there's air resistance, there's drag, there is friction and all these things, friction between the sledge and the floor and all. So suggest a reason why. You can say due to friction between the snow and the ground, or the sledge, the friction between the sledge and the ground. Okay, then another reason is maybe the ground is not level. Maybe it's not straight. Maybe it's like going up a hill like that. So if it's going up a hill, all the more there's more force that you need to put. Okay. So air resistance between the ground and the sledge. Or you can also say the ground is not level. Okay, anyone has any questions so far? Okay. Okay, let's look at the next one. The sledge starts from rest. So it starts from rest 0, no acceleration, no velocity, nothing. And then it accelerates at 1.5 meter per second until its velocity is 2.8 meter per second. Okay,
Yeah, but so soft. So soft.
So you can repeat again, sir, for B.
Just a second. Okay, so it says the sledge is starting from rest. That means starting at 0. Rest means haven't moved yet. And then it accelerates at 1.5 meter per second until its velocity is 2.8. So from 0, it went to 2.8, accelerating at 1.5 meter per second. State the relationship between acceleration, velocity, and time.
So what formula is this? I only know acceleration equals final speed minus initial speed over time.
Correct, what? That's the one, lah. So acceleration, yeah, that's the answer. Acceleration equals to final speed minus initial speed, or you can say change in, not speed, velocity. It's not change in speed. Velocity is change in speed over time. Acceleration is change in velocity over time. So acceleration equals to final velocity minus initial velocity over time taken. So that's the relationship, that's the formula. I repeat, acceleration equals to final velocity minus initial velocity divided by time. This one you all should have learned last year. Let me see what chapter this is. Chapter 4, page 86 of your textbook. Oh, you all didn't do velocity. Okay, so here it says, in the book, it says change in speed. Okay, now terminology, velocity is distance over time, correct? Acceleration is change in velocity. Okay, so let me see if you all do it in this chapter or not. No, you all don't do it here. Okay, change, so basically final speed minus initial speed. The better terminology would be for acceleration is change final velocity minus initial velocity. Okay, so that is for B1. So you can either say final minus initial, or you can straight away say change in velocity over time taken. Okay. Okay. Next, show that the time taken to reach 2.8 meter per second is about 2 seconds. So how do we do this? So we want to use the same formula. So we have force equals to change in acceleration equals to change in velocity over time taken. So they're saying show that the time taken. That means time is what we want to look for, lah. So time, if we rearrange the formula, how do I calculate for time?
Time equals velocity times acceleration.
No, not quite.
So the formula is change in velocity over time, right?
Correct. So change in velocity means basically
So that means
final
time equals acceleration over change in velocity.
No. The formula is acceleration equals to change in velocity over time. Okay. Let me just write it down here. So acceleration equals to change in velocity over time. So time, I want to find time. So I bring time up, I bring acceleration down. So time equals to...
I think it's because we really need the earphone. I think this is normal audio.
Pooja, you need to mute yourself.
I think we need earphones. But this one is Apple.
Okay, So let's continue. So we have acceleration equals to change in velocity over time. So when I switch it around, because I want to calculate for time, time is equals to change in velocity over acceleration. Because I want to find for time. So I make time the subject. So time I bring up, acceleration I bring down. So change in velocity over acceleration is, what is the change in velocity? From rest to 2.8. So what is the change in velocity?
0.8.
Sorry?
2.8.
Correct. So my change in velocity is 2.8 divided by my acceleration, which is 1.5. That's the given data from the question. Okay, so 2.8 divide 1.5. What do you all get? Punch into your calculator and see what do you all get.
1.866.
1.9.
1.8 is 1.9. So the question says, show that the time is about 2 seconds. So that's correct. So 1.9 seconds is about 2 seconds. So you can leave it at 1.9. Okay? So that's how you show. This is for this question. Make sure you have your units. Okay? This changing of subject is what you learn in maths. Okay, for example, right, let's say you have 5 equals to 10 over x. Find x. So I bring the x up, I bring the 5 down because I must make x the subject. So I automatically get x equals to 10 over 5, which is 2. You do like how you would do maths. Okay? Okay, let's continue. Okay, let's look at this.
Can you scroll up? So I'm not done copying the
I already erased it lah. Which one you haven't copied yet?
the one where you wrote the calculation.
Which one? The second one, is it?
No, the first one. No, yeah, the second one.
Okay, so I have acceleration equals to change in velocity over time. That is the formula. So to find time, I bring the up. Time equals to change in velocity. This one bring down over acceleration. Then I just plug it in lah.
Okay, Joe. Thanks. Okay, Joe, done.
Done? Okay. Let's continue. Okay. This velocity time graph shows the motion of the sledge as it travels down a hill. Okay, it's a velocity time graph. That means basically how you read the graph is as time increases, what happens to the velocity. Okay. So we're looking at the motion of the sledge. Motion of the sledge means the movement of the sledge as it travels down a hill. Okay. Calculate the distance traveled by the sledge. So when we have a velocity time graph, okay, remember when you have a velocity time graph, how you calculate total distance is, anyone knows?
Use the formula speed equals the distance over time.
No, you don't have to do that. When you have a velocity time graph, what you do is you need to find the area under the graph. The area under the graph gives you the total distance of the journey. Okay, so you have to remember this. This is a very common question that they ask in IGCSE. They will give you a graph, and then if it's a velocity time graph, they will ask you, okay, calculate the distance. So you have to calculate the area under the graph. Okay.
Is there a way to do it? Do we take our ruler and find the measurements?
So what you do is, again, like maths. So what you do is, the easiest way to do this is, you, oops, sorry, just a moment, yeah. Okay, so the easiest way to do this is, you divide it into segments, into shapes. So the first shape you can divide it to is triangle, and then you can have a square here and then a triangle here again. So you divide it into 3 shapes and then you calculate the area. Okay, everyone try. Divide it into 3 shapes and then you calculate each area. So like area of triangle is half times base times height. And then for rectangle or square is base times height. And then another triangle here is half times base times height. So that's how you calculate the area. Okay, you try, everyone try. Divide it into segments and yeah, try drawing it. Try finding the area.
Yeah, but then how will we know the measurements? Because we need something like a ruler or something, right?
No, there you see here. Wait, see, let me just take out the pen. Okay, so here you have this, right? So this is the triangle. So my distance is from here to here. What is the distance? This is 2, 3, 4, right? The length here is 2, 2.1, 2.2, 2.4, 2.6. This is 2.6. And then from here to here is 3.2. You take the measurement of the graph. Does that make sense? So
Yeah.
you take all the length based on the units on the graph.
Okay.
Okay, so everyone try, divide it into segments, and then try finding the area of each shape, and then you add it all together.
Sir, can I go to the toilet, please?
Yes. Find this area first, and then you find this area, then you find this area. The area is again like maths. You use the area of a triangle, area of a square or four-sided, and then area of a triangle again. Okay, so remember when you have a distance time graph, velocity time graph. To find the distance, you look at area under graph. Okay, come, let's see. Let's look at the first triangle on the most left. What is the area that you get? So area is half times base times height. What is the base? Anyone? What do you all get for the base? Okay, yes, 2.6, correct. So 2.2, because 3 is here. Okay, you must read the graph. Sometimes it's not 246, sometimes it's 234. So you have to look, if this is 246, that means, okay, that means here will be 3, which means this is 2.2, 2.4, 2.6. Okay, so this is 2.6. So half times base, which is 2.6 times, let's look at here. Oh, let me erase this. Let me use the straight one. So I have here, which is in the middle. So 3 and 3.5. So 3.1, 3.2, 3.1, 3.2. So it's about 3.25, not even 3.3 yet. So it's half times base 2.6 times height, which is 3.25. Everyone okay so far? Anyone not following? Anyone lost? Please say something now, if not I will continue. So this is 3.25. And then this height here is, that's the height, 3.25. And then the length here is 2.8. 2.6, sorry. Okay? Guys, please mute yourselves, yeah, if you're not answering me. Okay, so the height here is 3.25. So what is half times 2.6 times 3.25?
4.225.
Yes. Let me just double check now. So 2.6 times 3.25 times half. So the first one is, first shape is 4.225. Okay, meter per, distance, meter. Okay, and then let's look at the second shape.
So that's 3.25.
Yes,
the height.
3.25, yes. Because it's not even 3.3 yet. It's between 3.2 and 3.3, so I take 3.25.
Okay.
Okay, and then we look at the square, I mean the middle part here. So it's base times height. What is the base? So I start from 2.6 and I end at 10.1, no, 10.11 is here. So 10.2, 10.4, 10.5. So 10.5 minus 2.6 is 7.9. Okay, so my base is 7.9. Okay, 7.9, and my height is same as before, 3.25. So what is my area for the second diagram, second shape? How do I calculate? It's just base times height because it's a
25.7.
7.9 times 3.25, you should get 25.7.
20.
Correct. Or you can take, since the first shape you took 3 decimal, this one also you can take 3 decimal. So 25.675. So what I would suggest is, if there's so many decimals, then you just take 1 or 2 decimal places. But if it's 3, you only change it to 1 decimal place at the end after you calculate everything. So when you calculate them separately, you keep them as 3 decimal places first. Okay, so the second one is 7.9 times 3.25, I get 25.675 meter. Okay, and then we look at the third shape, also a triangle. So I have half times base times height. My base, I'm going from 10.5 to 14.2, 14.4, 14.5. 14.5 minus 10.5 will give me 4. So half times base, my base is 4. Okay, my base is 4. And again, my height, simple, 3.25 is the same. So half times 4 times 3.25. What do I get? I get 6.5. Okay, half times base times height. Remember, it's a triangle. So it's not just base times height. It's half times base times height. So half times 4 times 3.25. So you should get 6.5. Okay. All okay so far? Anyone lost? So now I must add all of them together. So I take 4.225 plus 25.675 plus
36.4.
6.5. Yes, you should get 36.4. Don't forget your unit, meter, because we're looking at total distance. So you should get 36.4. Okay. I'll give you all a minute to complete that. Anyone has any questions so far? These are the kinds of questions you will get in IGCSE. There's usually at least one question on distance, one question on this kind where they give you a graph, they ask you to calculate area and all that kind of stuff. Okay, if you're still doing, please raise your hand. If not, I will move on to the next question. Okay, your final answer should be 36.4 meter. So the first triangle's area is 4.225 meter. Second box, which is rectangle, is 25.675 meter. Third triangle is 6.5 meter. And then when I add them all together, I should get 36.4 meter. Okay, let's go on to the next one. Okay. State the equation linking average speed distance moved and time taken. So what would that be? Basically write down the formula lah, where you have distance moved, time taken, and average speed. So this is easy. Average speed equals to distance moved over time taken. That should be the formula. Average speed equals the distance moved over time taken.
What if I wrote average speed equals total distance traveled over total time taken?
Can. But the only issue with that is because the question says state the equation linking these three things. So you want to use the three things that they have mentioned. But the answer is correct because that is the formula. But you want to, because it says the equation linking these three things, so you want to put what they have given you.
Okay.
Okay? Okay, let's continue. Calculate the average speed of the sledge for the whole journey. So average speed, like you mentioned earlier, is distance over time. Distance moved over time taken. So the distance that you moved is what you calculated just now, 36.4 meter. And divided by, what is the time taken for the whole journey? Look at the graph. He ends after
14.5.
yes, 14.5 seconds. So you take 36.4 because speed equals to distance over time based on the formula for the question you gave just now. So distance moved will be 36.4 divided by the time taken, which is 14.5. So what do you get when you divide that?
So 36.4 over 14.5.
Yes. Because distance, we calculated distance, all the areas just now, when you add them together, and then divided by the total time. So based on the graph for the whole journey, because the question says for the whole journey. So whole journey, 14.5. So
So I got 2.51.
correct. So 2.51 meter per second. That is your average speed. Yeah, correct. 2.51.
So any news regarding exam?
Any news regarding exam? I think they will send out an email soon.
Or
Yeah, you should get an email soon lah.
but
About
confirm there's an exam.
Yes.
Is it online?
Yeah lah, it will have to be online, but they will tell you all how to go about it and all lah.
Will it be open book?
That one I'm not sure yet. That one we are yet to discuss. But they will let you all know lah how to do, what to do, where to go and do. I mean, like which website and all these things lah, and what are the dates and all.
Okay.
Okay, let's look at the next one. Okay. Okay, a student investigates terminal velocity. Okay, she uses a tall glass tube with oil, filled with oil. She drops a metal ball into the tube. The ball falls through the oil. Now, before we go through further, what is terminal velocity? What does it mean by terminal velocity?
When your moving force equals to the drag, when your drag equals to air resistance.
Okay, so basically, yeah, so that's essentially it. So in a more, what can I say, in a more layman term, okay, basically means that, let's say I have a free falling object. So like an object that's just free falling, okay? When that object eventually reaches, when the resistance of the air or whatever medium it's traveling to it has all come to a point where there's no further acceleration. So the air resistance equals to the drag, equals to the gravity and all that. So the forces are all balanced basically. So the object that is free falling will be moving at constant speed. It won't be accelerating anymore. So for example, the classic example is a parachute. So let's say you jump down an aeroplane. Okay, you have a parachute, you do skydiving. Okay, so you jump out of the plane. The first thing is when you first jump out, you will be falling down really fast. Acceleration, you'll be going down, falling very fast. And then the moment you open your parachute, you will move up. So it's constant acceleration, but now upwards, very fast also. And then after a while, you will slowly balance in the air, and then it will just be constant speed, really slow in fact. That's when all the forces around in all direction that is pointing towards you, moving away from everything, they are all balanced. So that means we say that you have reached your terminal velocity. Okay? So you are in constant speed. Because you're a free falling object. At this point, you're known as a free falling object when you're jumping out of the plane, right? And then you reach a point where all the forces around you are balanced. So you reach your terminal velocity. Okay, so it's basically you're moving at constant speed with no further acceleration as well. Okay, so you have a metal ball falling through oil. Now, use ideas about forces. Okay, so it says there, use ideas about forces. So you want, when you write your answer, you want to talk about forces to explain how a falling object can reach terminal velocity. So how a falling object, so these are keywords you want to take note of. Okay, how a falling object, so you want to use forces to explain how a falling object can reach terminal velocity. Okay, so anyone wants to try? So you want to use forces, you want to talk about forces. So we have a falling object. So you want to talk about the forces around a falling object and then how it reaches terminal velocity. Okay, anyone wants to try? Okay, let's start with this now. Okay, now I have a falling object. Okay, so now when an object is falling, when something is falling, is it falling upwards or downwards?
Downwards.
Sorry?
Downwards.
Downwards, correct. So when the object is falling downwards, what is the force that is pulling it down?
Gravity.
Gravity. So the first point you want to say is the falling object, okay, has a downward force, which is gravity, due to the gravity of the object. So we say gravity or we say weight, because the weight is due to the gravity anyway. So your first point you want to say is the falling object has a downward force due to gravity, or the object has weight due to gravity acting on the object. So that's your first point. It says 5 points here, 5 marks. Okay, so number 1, the falling object has weight, or the falling object has a downward force due to gravity acting on the object. That's number 1. Okay, and then continue. Number 2 is because of this this gravity and all, right, this falling object is accelerating.
Please repeat that one.
So number 1 is the object has the falling object has downward force due to gravity acting on that object. This number 2 is this causes the object to accelerate downwards, falling downwards. So this causes the object to accelerate downwards. That's number 2. This object causes the this causes the falling object to accelerate downwards. That's number 2. Okay, and then number 3, when you're falling downwards, there's something that is pushing you up as well. So number 3 is there is an upward force, okay, which is the drag in this case. There is, so you can say there is drag, which is opposite to gravity. You say the falling object, or you can say the falling object has a drag that acts opposite to the direction of gravity, pushing the object upwards. So you must imagine this, I have an object, the upward force, okay, let me just draw it here. So I have an object like this, let's say. I have a downward force, which is gravity, and then I have an upward force, which is drag. Okay, so basically I'm saying that this object has weight pulling it down, and then so it accelerates. And then there's also an upward force, which is opposite to the gravity, which is the drag. Okay,
Yeah.
so I have 3 points, and then I continue. The 4th point, say eventually drag is equals to weight. So eventually after a specific time, the falling object, right, the downward force, it will equal to the upward force. So drag will equal to weight eventually. So that's point number 4.
Miss Sharina,
Yes.
you just say we ignore air resistance in a situation where we shoot a gun and we ignore friction and other forces. Would that mean the bullet could travel forever without stopping?
Sorry, can you repeat that, please?
Just say we shoot a gun, right? But then we ignore air resistance and friction and opposing forces. Does that mean the bullet can travel forever?
Yeah. If there's like no drag at all, no air resistance, nothing, yeah. No
But then won't the energy be converted to other types of energy?
Yeah. In the process.
But if we ignore both of that, then the bullet can travel on forever, lah.
Can? Okay. So I repeat, number 1, the falling object has a downward force due to gravity acting on that object. Number 2, this causes the object to accelerate downwards. Okay, and then number 3, there is drag or upward force acting on the object, which is opposite to the weight, opposite to the gravity. Okay, drag is the one that is pushing it upwards. So downward pulling it is gravity, the weight. Upward is drag. So number 3 is there is a drag, or there is an upward force opposite to gravity that is acting on the object. Okay, remember, we are using force to explain a falling object, how it's going to reach terminal velocity. Okay, so now I have gravity pulling it down and drag pushing it up. Then eventually, so this is point number 1, 2, 3, 4. So eventually, for point number 4, eventually drag will equate to weight. So that's number 4. Eventually, drag will equate to weight. When drag is equal to weight, number 5, you say the resultant force is 0 because now it's balanced. The resultant force is 0, causing the object to travel at constant speed. Okay, the resultant force is 0. Causing the object to travel at constant speed. The resultant force is 0, causing the object to travel at constant speed, full stop. The object has reached terminal velocity. You end with that. Okay, because the question says how it reaches terminal velocity. So you end with the object reaches terminal velocity. Okay, I'll just repeat that. Resultant force is equal to 0, which causes the object to travel at constant speed. Full stop. And then the object has reached terminal velocity, or the object has reached terminal velocity. Okay. So it's 9:58 now. I'll give you all 5 minutes break. You come back at 10:05. Okay, so just go take a drink or go stretch and all. Come back at about 10:05. Okay? Okay, let me just call out. Elijah?
Yeah, Chan. Yeah.
Okay. Okay, Pooja is here, Abigail is here. Jared?
Here, Cha.
Okay, Celeste? Isaac? I heard Isabel just now. Judith?
Still trying to do chat.
Havishka?
Yeah, sure.
Pooja? Ricardo. Okay, Pooja is here. Yeah. Ricardo?
Yeah, sure.
Okay. Okay, let's continue. Okay. So, okay. Next one. Describe how the student could find out if the ball reaches terminal velocity as it falls through the oil. In your answer, you should include the measuring instrument that the student will need, the measurement that she should take, how she could use her measurements to find out if the ball reached terminal velocity. You may include a label diagram in your answer. So now she's going to drop the ball into the tube of oil, and she wants to find out terminal velocity. So how does she do that?
Can she use a speed meter, Cha?
Okay, so yes, you need some, what do you mean by speed meter?
Like something to calculate speed, or you can use a light meter also. I mean a light gauge. Sorry.
Okay, yes, you can use light gauge. Now, the key point here is you want to look for velocity. So how to calculate velocity? Velocity we know is change in, you have your speed unit and your time. So that means you want to find out the speed and you want to find out the time. So to calculate this, you need distance and time, because you want to calculate velocity. So you want to have distance, you want to have time. So you want to calculate time, you need some sort of timer. So the measuring instrument needed will be a stopwatch or a light gate or a timer, some sort of thing to measure time. And then you will need to calculate distance. So distance, you want to go from, let's say, the top to the bottom, but I need to know what is the length. So how to calculate the length? What do I use?
That thing, that tape thing. I forgot the name of it.
You can use a
measuring tape.
Yep, you can use a measuring tape, you can use a ruler. So you need some sort of measurement to calculate the distance from the top of the glass tube to the bottom of the glass tube. Okay, so the first thing, the measuring instruments you will need a stopwatch or a timer, and then you need a ruler or measuring tape. So those are the two main things you need, because you want to calculate distance over time, because that's what gives you your velocity, your speed, because they're asking for terminal velocity. Okay, then the next is the measurements that she should take. So if she wants to take, you have to take the distance, you have to take the time. So how is she going to use, what is she going to do? So I drop the ball in, you start your stopwatch. So the first thing to do is you want to take the time for the ball to pass between the 2 points. So you want to calculate the time taken when it starts, when the ball is dropped and when it reaches the end. So that's the first thing. Take the time for the ball to pass between the 2 points, for the ball to pass from the top of the glass tube to the bottom of the glass tube. That's the first thing. And then the second thing is, I also want to measure the distance between the 2 points. So the second thing is you want to determine the distance. You want to measure the distance traveled. So the start of the oil to the bottom of the glass tube. Okay, so the first thing is take the time taken for the ball to pass from the top of the glass tube to the bottom of the glass tube is measured. And number two, the distance between the distance traveled by the ball is also measured using the ruler.
So you can repeat the part.
The first one is the time taken for the ball to pass through the tube, or the ball to pass from the top of the glass tube to the bottom of the glass tube is measured. The second one is the distance between the top of the glass tube and the bottom of the glass tube is measured also. Okay, and then it says here how she could use her measurement to find out the ball reached terminal velocity. So once she get the measurement of the time and the distance, she used speed equals to distance over time. So she calculate the speed, which is equals to distance over time. So that's the next point. You want to say, using the formula speed equals to distance over time, she indicates if terminal velocity is achieved. She indicates if terminal velocity is achieved. Okay, then I want to add something to the steps first. Okay,
Yeah.
but write this down first, yes.
So how does a person measure terminal velocity,
Okay, I will
how will they know?
I will tell after this. So after this, I will tell one more step that you need to include in your the second part, and then I'll tell you how they get terminal velocity. Okay, so I repeat the third one first, the last part. So using speed equals the distance over time, she indicates if terminal velocity is achieved. So how from speed equals the distance over time, we get to see if terminal velocity is achieved. So this is what brings me to the next part. So on the steps before, right? So we talked about the time was taken for ball to pass between the 2 points, the top and the bottom, and then we determine the distance as well. So what you want to include in that part, the third point for that part is, oh, now, okay, remember like the parachute and all. So when you drop the ball in, right, the ball is going to go fast first, just like the parachute when you jump down from the plane. So it's going to go fast first, and then it might go up a bit, and then only it will slowly reach a balance, and then it will slowly come down. Okay, so then it reaches terminal velocity. So what you want to add to your steps is, okay, so the first one was the time taken for the ball to pass. Okay, the second one is you want to determine the distance. Now, the different that is for normal speed equals the distance over time. But when you have a situation like this where the ball is going to drop and then it's going to linger a bit there and then it's going to move upwards a bit, then only reach terminal velocity. So you want your answer, you want to tweak it a bit. So take time. So the time taken for the ball to pass between. So what's going to happen is you drop the ball. Okay, listen first. You drop the ball, and then you see. Let's say you. Let me just draw here. Okay, so you drop the ball here. Okay, then let's say it's stuck here. It's here because it's oil. If the oil or water, if it's just air, then it will just pass through easier. But this is now oil. So what happens? You drop the ball, it stops here, and then it lingers here a bit. It goes back up. So you want to take the time taken when it drops from here to here, these 2 points, and then you take the distance. So you take the distance, let's say 5 centimeters, and then over the time, let's say it took 2.2 seconds. And then it reaches, after a while, it will drop again, maybe drop a bit only. And then you take the distance here, between here and here, and then maybe it took about 3 seconds. And then the ball is here now. And then it drops a bit more, let's say until here. Then you take the distance over time again. And then you keep repeating it. Okay, you repeat the readings here, wherever it drops. Okay,
So
at some point, so let's say I do, okay, let's say I finish it. Distance over time. And then here, again, and then so at some point you're going to get the same reading. Maybe at the start here, maybe you start with 2 meters per second, and then maybe here is 1.8, and then maybe here at some point you're going to get the same reading. You're going to get 1.5, 1.5, no acceleration, constant speed. So when you calculate like that, then you will know, okay, this part here, it has reached terminal velocity because all the velocity is the same. No more constant speed, no more acceleration. That's when you know that, okay, at this point here, it has reached terminal velocity. So you want to tweak your answers a bit. Why I asked you all to write that first, then I tweak it is so that you all get an understanding of speed, velocity and terminal velocity. So for the first one, the time taken for ball to pass, instead from the top of the glass tube to the bottom of the glass tube, you cancel it. Don't erase, because I want you to, when you do your revision, I want you to know the difference between velocity and terminal velocity. So you either cancel or you can write bracket would be better, bracket at the top or at the side. So time taken for the ball to pass between 2 points. So you don't say between the top and the bottom of the glass tube. You say time taken for the ball to pass between 2 points, because maybe this point and this point, this point and this point, this point and this point. Okay, so the time taken for the ball to pass between 2 points is measured. Okay, so you just edit your answers. Don't erase, please don't erase so that you know the difference. Number 2, the distance, we talked about the distance between the glass tube top and bottom, right? So the distance between the 2 points is measured. So instead of top and bottom, say the distance between the 2 points. So you edit it. Okay, and this is the third one you want to add. Repeat these steps at the lower part of the glass tube. So basically at here, so not just once or twice, but even at the bottom. So repeat these steps at the lower part of the glass tube, because towards the lower part is where you're going to reach the terminal velocity eventually. So repeat these steps at the lower part of the glass tube. Okay, I'll repeat. So number 1, the time taken for the ball to pass between 2 points is measured, because between top here and then maybe a bit down here, and then here and then here, between here and here. So that's why between 2 points, not between the top and the bottom of the glass tube. So the time taken for the ball to pass between 2 points is measured. Number 2, the distance between the 2 points is measured. And number 3, these steps, repeat these steps at the lower part of the glass tube. Okay, which is why at the bottom of your answer, when I said use speed equals to distance over time, this will indicate if terminal velocity is reached. Because if you calculate distance over time for each, at some point you're going to see the pattern, the answer when you calculate distance over time is going to be the same. So when you keep getting the same value after a while, that means it has reached terminal velocity. So it's constant speed already. No more acceleration or deceleration or whatever. Okay? Okay, anyone has any questions? Elijah, you wanted to ask something just now?
Raja, you already answered my question.
Okay. Yeah, I'll give you all a moment to just quickly write that down, and I will continue.
Check, repeat the part again.
Which part?
The part that we're supposed to write down the stuff.
So the part that you want to edit is, so when you talked about measuring the time, so the first thing is the time taken for the ball to pass between 2 points is measured. So not between the top and bottom of the glass tube, but between 2 points in the glass tube. So time taken for the ball to pass through between 2 points is measured. Number 2, the distance between the 2 points is measured. And then number 3, repeat the steps for the lower part of the glass tube.
Okay, sure.
It says here you may include a label diagram. So you can also put this diagram if you want to, the one that I've drawn. Okay, and then you just label it the ball falling also, because it is labeled diagram. So you can also put this diagram if you want. So the diagram will help you to write your answers down. And also the good thing about diagram is, if let's say you're writing something down, you can say, okay, based on the diagram when it falls. So you can say based on the diagram. So you don't have to explain very in detail, because there's a diagram that shows it. That's the advantage of having a diagram. But always remember, when you have diagram, you must label the diagram. Okay, anyone still writing? Please raise your hand. If not, I'll go on to the next part. Okay, let's move to the next part. Okay, this is the last one. Okay, a student investigates the motion. Motion is motion of different falling by measuring the time taken for empty cupcake cases to fall from a window. So these cupcake cases are empty and they're falling from a window, and measuring the time taken. The student drops one case from the window. He repeats the experiment with two cases stuck together. So first is 1 and then 2 stuck together, then with 3 and then 4. So of course, when you increase the number of cups stuck together, you're increasing what?
Mass.
The mass, which is stated here, different falling masses. Name 2 measuring instruments that he would need for this investigation.
Stopwatch and a really long measuring tape.
Just a second. Okay, yes, so he will need a stopwatch because he wants to see how long it takes for it to fall.
Measuring tape.
Yes, a measuring tape. So measuring tape, a stopwatch. And then you also want how to measure the mass of the cups.
The balance.
A ruler also can. Yeah, you can use a balance. But here it says 2, so either 2, any 2. So a stopwatch, a ruler or measuring tape, and then a weighing balance to measure the weight of the mass of the cups. Okay, what are the dependent and independent variables in this investigation? Dependent, what is the, okay, independent first. So independent is what is constantly changing. What is changed in this experiment? First is 1 case and then 2 case. So what is changing?
So independent is constantly changing, Aja.
Independent is, yeah.
So I thought it's dependent.
See, independent means dependent means it's dependent on something. It's dependent on the change. Independent means you just change by itself. It can be 1, it can be 2, it can be 3. Dependent is because of the changes, whatever is dependent on the change is changing. So independent is what is changing. So what is changing here?
The mass of the cupcake.
Correct. So independent is mass of the cupcake cases, and dependent, what would dependent be? Dependent is basically what you're measuring. When you change the independent, which is the mass, what is changing also? What is the dependent variable that is changing on, that depends on that?
Time.
Yes. So time taken for the fall.
Hey Jared, you're putting your mic in your mouth and talking. Put it away from you. So loud.
Okay, so independent, the second one, independent is mass of cupcake cases. Dependent is time taken for the fall of the cupcake cases. Okay, state one factor that the students should keep constant in order to make this investigation fair. What must be kept constant?
So he must make sure that the weather is alright, otherwise there'll be too much of forces acting on the thing.
Okay, so one thing he must make sure is, if let's say the first fall, let's say the first cupcake fall got no air, no wind. Suddenly the second cupcake got wind. So can he continue the experiment?
So the answer is wind speed, Aja.
No, can he continue the experiment or not?
No.
Cannot, because the wind will now affect. So number one is you must make sure the weather condition is constant. Or like if it's still air, means make sure it's still air lah. Wind also you cannot use. You cannot say all have wind, because the wind will be strong in one and then maybe weaker when it's the other cupcake cases falling. So must make sure that the weather condition is constant. The weather condition is the same. So still air. no wind. What else must be made sure that is the same? There's a few things that must
So the material of the cupcake bag thing.
okay, so the type lah, so the type of case. So if it's all from one type, you must use all the same type, because when it's different material, it will change the mass, it will change the friction with the air and all that. So the material used for the cases or the type of cases used. Okay, then Pooja also mentioned the height, correct? The height from which the case is falling. So if you drop it from a certain height, you must drop all the other cases from a certain height as well. So the height from which the cases are dropped from, that also must be kept the same. Okay, Abigail says temperature. So temperature is similar to the weather condition. So if it's a certain temperature, you make sure that temperature is the same. Don't one you do at night when it's colder, one when it's warmer and all that. So weather, that will fall under weather condition. Okay. Okay. Next, D. A student draws this table to record his results. Add a suitable heading for this table. So what would be the two headings? If let's say I want to record my data, right? What would my two headings be? What am I recording? What's the first one? What's my independent variable?
Mass of cupcake case.
Correct. So mass of cupcake case in grams. So you must write here mass of cupcakes cases in grams. And then in bracket put G. You must put the unit. So mass of cupcake cases in grams, grams, bracket G. And what is the other side? What am I measuring?
Time.
Okay, time taken for cupcake case to fall in seconds. And then bracket S. Must always put unit in graph, in table.
But you can't really get a very accurate result, right? Because in open weather, it always changes, such as the wind speed and all.
Yeah. So your which is why a lot of people, what they do is when they do experiment, they repeat the experiment.
Oh.
So you repeat the experiment, or you do a few times, then you get the average. Especially when it's dealing with things like this where the weather is not constant and all that. So they will take a few readings. Let's say for one case, let's say you do experiment for one case, two case, three cases, and then you repeat again. You do the same thing again for one cupcake case, and then two cupcake cases, three. And then you do a few readings, and then you calculate the average. So that's why people usually repeat experiments. When you do experiment, you must always repeat it. Okay, so that is that. Okay. Okay, let's look at this. State one way that the student can improve his investigation. What is one way to get a more accurate result, basically? Like you want to improve your investigation.
Repeat the experiment.
Correct. So you repeat the experiment and then you find the average time taken for the cupcakes to fall. So all these great scientists who do experiments and come up with theories, right? They do the experiment countless times. Okay, when you go to uni, if let's say you're doing a science degree or master's, or you're doing a thesis for PhD and all that, final year project and all this, when you do experiments, you have to repeat your experiment, because when you write out your paper, when you write out your report, right, you must make sure that the conclusion that you make is a valid conclusion. And how to know if it's valid or not is after you do a few times, because the validity of your conclusion is based on, if let's say your lecturer or another student looks at your paper and says, okay, I'm going to repeat this experiment and see and test this conclusion. Your conclusion, when they test the conclusion, right, by doing the experiment, right, they must somehow come to the same conclusion. That's when we know that the paper that you have written or the experiment that you have done is valid, or it has done professionally, or it has done properly, scientifically. Okay, that is why repeating experiment is very important. Okay. Next, the student notices that the cases accelerate and then fall at constant speed. So basically reaching terminal velocity after a while. The arrows in the diagram show the size and direction of the forces. So the arrows in the diagram here, the size and direction. So the bigger the arrow, the bigger the force. Acting on a case at different points in its fall. Label the force on the middle diagram. So going down, what would it be?
Gravity.
Gravity or weight? Okay, when we look at terminal velocity, try to use weight, because the weight is the one that's pulling it down. Okay, so try to use weight more than gravity. So using weight, so down is weight, up will be?
Resistance.
Okay, or a better terminology is drag. So when we're looking at terminal velocity, try to use weight and drag. That is the more accurate terminology. Okay, so down is weight, up is drag. Okay, anyone has any questions so far? Okay, let's go to the last question then. Explain why the case accelerates and then falls at constant speed. Okay, anyone wants to try? It's essentially what we already talked about so far.
Because
Yes.
at first the forces are not balanced, and after that the weight equals to the drag, so then it balances.
Okay, so that's essentially it. But to write it out properly, okay, we want to talk about number one, why. So there's two parts to this question. Explain why the case accelerates and then falls at constant speed. So you must talk about both, as why it accelerates and then why suddenly it's constant speed. You have to cover both in order to get your full marks. Okay, there's two parts to this question. This is how we answer questions. Okay, you must see there are two parts here. It accelerates and then it falls at constant speed. So you have to talk about both. So we look at the first one. Okay, The first one is it accelerates. Why it accelerates? Okay, so you write down. At the start, there is unbalanced force. The weight is greater than the drag. Okay, at the start, there is unbalanced force. The weight is greater than the drag. This causes acceleration. Okay, at the start, the weight is greater than the drag. This causes acceleration. Okay, then you continue by saying, okay, the forces start being balanced at the bottom. Okay, the forces start getting balanced at the bottom. Okay, eventually weight is equal to drag, and therefore there is no acceleration. Okay, the forces start getting balanced at the bottom. Eventually, weight is equals to drag. And therefore, there is no acceleration. Or you can say, and therefore, the speed is constant. I think that would be better. And therefore, the speed is constant. Or you can just continue, you can write both. And therefore, there is no acceleration. The speed is constant. Okay. And then you end by saying the case has reached terminal velocity. Okay, the forces start getting balanced at the bottom. Eventually, weight is equals to drag, and therefore, there is no acceleration. The speed is constant. The case has reached terminal velocity. Okay, any questions? Okay, so terminal velocity is last year chapter. Chapter what? It's under air resistance. Yes, chapter 1.6, page 18 of your textbook. Okay, They talk about air resistance and they touch a bit on terminal velocity. If you look at page 19, they talk about the whole parachute situation. It accelerates and then reaches terminal velocity and then decelerates and then terminal velocity again. Okay, if you want to know more about terminal velocity, you can always just Google it up. Google terminal velocity, and there'll be a lot of articles about it, different situations and all that. Or you can also Google examples of terminal velocity. Okay, for example, let's say I Google here. Okay, let's see. Okay, can you still see my screen? Yes?
Yes, sir.
Okay, so if you go to Google, okay, you can just click here, examples of terminal. Can you see me typing or is it frozen? Can you see me typing?
Yes, teacher.
Okay, okay. Okay, so you go examples of terminal velocity. You can look at images as well. And then you can see so many examples. Okay. Here. A lot of examples you can see. Okay, or you can also go to, okay. Here. Definition, examples, and facts. You see here, it says definition, examples, and facts. So you can just click on it. And then it will explain to you. Okay. Yeah, and then you just keep going. You can look at, there's a lot of sources online. Okay. So that's basically it for today's class. If you all have no questions, then we will end. Anyone has questions?
No.
No? Okay. If that's the case, just to check, your workbook, have you all done, I know you all have done page 80 and 82. Okay, please do 81. So it's on an experiment. It's not a difficult experiment. I know you all have done 79. Have you all done 76?
In our workbook.
Yes, workbook. Have you all done 76?
Yes, sir, we're done.
77?
No.
77, no. 78 also, I think, no. So please do 77, 78, and 81. Okay, 77, 78, and 81. Okay?
Okay.
Sir.
Okay, 77, 78, and 81. Okay, and then I will post some more questions on Edmodo as well. I will also send the picture on, yeah, I think on WhatsApp is easier, for those of y'all who don't have your workbook. Okay?
Alright, sir.
Okay, that is all for today. Thank you, class.
Thank you, Michelle.
Thank you.
Thank
Thank you, sir.
you.
Have a great day.
Good job, bye.
Thank you. Bye.